As we continue to explore the ACI logical model, the next step up from bridge domain is the context. And by the end of this nugget, we're going to realize that a context is really pretty close to a VRF, or virtual routing and forwarding instance, within the ACI fabric, while also serving as a container for all of the other constructs we've talked about up to this point. Once upon a time, we had simple switches that would have a single MAC address table. And over time, we said, you know what? We need the ability to create virtual local area networks, which are called, of course, VLANs. And so what we did was we would split the switch in half, and we'd have an A side to the switch, and we'd have a B side. So VLAN A and VLAN B. And guess what? Both of these would have their own MAC address table. So A would have its MAC address table, and B would have its MAC address table. So this is one physical switch, but it's logically divided. And again, the tables are kind of what define the fact that we have two different VLANs. The different tables are what lead us to isolated broadcast domains, which is another way of describing a VLAN, is that it's a dedicated broadcast domain. Well, we have the same concept in the routing world. Just like in the switching space, we can take a router and we can split it, such that we have two different, not MAC address tables, but two different IP routing tables. And these IP routing tables give us independent routing domains. What do we mean by that? Well, within a single broadcast domain, we can have duplicate MAC addresses between the two different VLANs. Well, same with the routing world. We can have duplicate IP addresses between these two domains. So what do we call this concept? Well, instead of a virtual LAN, we call this a virtual routing and forwarding instance, or VRF. So again, we have VRF-A and VRF-B. So there are a lot of parallels between VRFs and VLANs. The only real difference is that most network engineers have a lot of experience around VLANs and less experience around VRFs. But we can't let that stop us from delving into understanding more about them. All right, so we're here to talk about context. All of this talk about VRFs must be heading somewhere, right? Well, that's absolutely true, because in ACI, we have this notion of the context. And we already said it, right? A context is roughly the equivalent of a VRF. In fact, there's a stronger parallel between context and VRF than there is between bridge domain and VLAN, to the point that Cisco has actually started to call context VRF. But we have to be aware that really, from a technical perspective, ACI is going to call them contexts. Now, within the logical model, we can have multiple bridge domains attached to a single context. And of course, we can have multiple contexts as well. We could have context B over here that map to the exact same tenant. We'll talk about tenants in the next nugget. And we have separate bridge domains mapped over here. And just like with a traditional network, we could have a subnet assigned to a particular bridge domain. Let's say 10.1.1.0/24 could be part of this bridge domain here. And yet within the same tenant, in this separate context over here, we could also have 10.1.1.0/24. Why would we do this? Well, I mean, we could have multi-tenancy. Now we could argue that ACI tenancy should happen using the tenant construct, and I would agree with that. However, within a particular tenant, we might say, hey, we need multiple VRFs for one reason or another. Maybe it is multi-tenancy. Maybe it is a security decision that we're going to route our DMZ traffic in a separate VRF. Oh, and what if my company made an acquisition? And the acquisition, they use the exact same IP address space. Not too uncommon. We do like the 10 dot something range. And so maybe we overlap in IP addresses, and in the meantime, while we are merging our networks together, rather than re-IPing everything, we simply decide to place our two networks in separate VRFs. The primary consideration we need to make here is that we can't actually route between these using normal methods. We'd have to get into VRF route leaking, and even then we can't leak the same route because then we'd have problems with duplicated IP addresses. So we need to understand fully what we're signing up for when we create multiple contexts. That said, if your question is, Jeff, I don't really want to use contexts or VRFs, can I just create a tenant without them? And the answer is no. Every tenant has to have at least one context, because we can't assign a bridge domain to a tenant directly. We can't do that. Cross that out. We have to have a context here so that we can map the bridge domain. And so at a minimum, we have to have one context, even if it's a catch-all context that's going to have every bridge domain associated to it. Contexts are isolated layer 3 domains within a single tenant. We map endpoint groups to bridge domains, and then bridge domains we have to assign to a particular context. Now, contexts allow us to duplicate IP addresses, but keep in mind that there's no normal way to route between contexts. We would need to do some advanced feature configuration in order to route traffic between the two environments. I hope this has been informative for you, and I'd like to thank you for viewing.